Hello everybody, this will be a quick video about the normal curve with no numbers. The normal curve is a way of looking at things in nature and in manufacturing that are distributed normally. If we take these pumpkin seeds and we lay them out and kind of organize them like a bar graph by their sizes, you're going to have big ones and little ones, and we're going to kind of lay them out. So here we've got littlest one over here, or the littlest one that I found so far, and a big one over here. So if we kind of make this into a bar graph and keep putting the ones together by their size, here's smaller, bigger, then eventually usually what happens is that you end up seeing a familiar shape. And the familiar shape is called the bell curve. But let me keep organizing a little bit more and see if you see the bell curve forming. Let's put a couple more together. So as we grab them and put them kind of with their same sized beans, not beans, pumpkin seeds, whatever it is that we're using. That's a little bigger and that one's a little smaller. We keep going. We're going to grab more. Actually, I'm going to pause it and grab a whole bunch more and show you. You can kind of see it forming. If you pretend like we're making a histogram by the size or weight of these beans. Here's the first little bar for bar graphy bar. Second bar, third bar, fourth bar, fifth bar, sixth bar, and there's our seventh bar. Small ones, average ones, and bigger ones. Okay, let me pause and then I'll show you a bunch of them all together. Okay, so Amy and I finished organizing our pumpkin seeds here by size. Big guys over here, little guys over here, and all the guys in between. So what would you call kind of these guys? What would you call them?
Middle?
Middle. Okay, the middle or median, average, kind of like, these are just like normal pumpkin seeds right in here. Okay, so, and then what do you want to call these guys over here?
Biggest.
Big ones. Okay, and what about these guys?
They're the teeny ones.
Teeny ones. Okay, so this is normal language we're using here instead of like fancy statistics language. And this is to represent what happens when you go from doing a histogram, saying that these are the columns, or what are those things called? The bars in a bar graph, but they're touching when it's a histogram. So, and then this becomes a continuous curve instead of a discrete curve that's called the normal curve if we kind of fit it. We go like this. Okay, and there's a whole lot more math to this, but I really kind of, and this is supposed to be symmetric, but mine never looks symmetric, but it looks almost just like the pumpkin seeds, so we're good. And what the basic part of the normal curve is that it kind of gives you a range for what's average, above average, and below average. Okay, we're going to get a lot more specific than that, but I kind of wanted you to have a picture of what it was. And in nature and in manufacturing, all or many things actually are normally distributed. This was pumpkin seeds. I want to do another example with something that's not going to be quite as diverse as the pumpkin seeds were. I'm going to do something that's manufactured rather than natural. So here we go. We're going to get rid of the pumpkin seeds. I don't know if they're going to come back again or not later, but we're getting rid of pumpkin seeds. And we're going to put pennies out. So another P thing, okay? But these are manufactured at a mint, right? So if we actually had a scale over here, let me pretend like I'm weighing them. Whoop! Weighing them. I'm not really weighing them. And we distributed them by their weight. A whole bunch of them would weigh pretty close to the same. Does that make sense? Because they're manufactured at some fancy, very accurate kind of plant. Uh-oh, I'm running out of space. I might need to zoom out. Let's zoom out a little bit and see if we can still see. Okay, yeah, here we go. And most of them are going to be pretty close to the same weight. This would be the weight of an average penny right here. And then there's some pennies, probably not even that many. Let me make this a little more realistic. There's a couple of pennies that weigh a little bit more or a little bit less. And then every now and then a penny gets a little bit extra copper or whatever fake metal they use now. Is it still copper? Do we know? I think so. I don't know. There's probably still some copper in it. And then some of them don't get quite as much. But basically, for pennies, there's not very much dispersion or variance. So if we were to compare normal curves for pennies and pumpkin seeds, it would go something like this. Let's make this be the pennies. Whoosh. And I don't know what pumpkins weigh, but they weigh more. Pumpkins, pennies weigh, but they weigh more than pumpkin seeds, right? Like you weigh them in your hands, it weighs more. So we're going to say that this is where pennies are, and that this is where pumpkin seeds are. Okay, so both of these curves have an area of 1 underneath them, but the penny curve has a small standard deviation, and this is pennies. I should write pennies. I need to put a penny on it. Boop, pennies, pennies. And the pumpkin seed one, boop, pumpkin seeds, pennies. I know a P wasn't going to help. The pumpkin seed one has a large standard deviation. That symbol is standard deviation if you have not seen it before. I'm going to do one more example, quite a bit like this, actually way too much like this now that I think about it, but it's one that frequently helps people think about the basic meaning of standard deviation and the normal curve. Let's look at a very common one. We've got, why is this not straight? We've got, this is the normal curve. Oh, actually, I'll do one that's a little more controversial, of women. Okay, this is normal women. There's women that have normal weight, BMI, height, whatever you even want to call it. And then let's do BMI. Do you know BMI?
Yeah.
This one's actually published somewhere. You guys should look it up. And then over here, so this is women's BMI. BMI, body mass index. They're a fraction of their height and weight. And here is the normal curve for superhero women in cartoons. We've seen that before anywhere. Yeah, their style's good. So their normal curve kind of looks like them, except that it's a little bit less voluptuous. And then we could even do also, let's now forget the superheroes and go to something else that's, let's talk about men now. For me, I'd rather look at men anyway. So shall we look at men? Okay. Sorry for the gentleman watching this, but whatever. Okay, so here we have men, which is not symmetric, but it should be. If so, this is tall men over here, and over here would be less tall men that are maybe more agile and can run fast or something, but they're less tall. Fine, I don't care. And here is average men, and I think right around here would be 5'10". The average Joe in America is 5'10". And then if I draw one that's right here, what population of men that we know in this area could this possibly maybe be?
Basketball players.
Basketball players, yes, because we're talking about height, and so the average basketball player is definitely taller than the average man. And so, and over here, Amy's telling me that we have the horse jockeys. So, which are, it is. They're little. They need to be, because the less weight you have on the horse, the faster the horse can go. And awesome. Okay. My first boyfriend was like really short. Totally irrelevant. Okay, we're ending the video. But so that's the no numbers version of the normal curve. In the middle of any normal curve is kind of average-ish, looks average-ish. Over here is above average over there is below average, whatever you're measuring, but that is what the normal curve does. And the standard deviation tells you how much variation. So for this, which we decided was men, just any old men all over the place, or any young men, just men, and this was NBA players or whatever. Okay, so this one has the small standard deviation because all NBA players are tall. Okay, so they're all kind of over here on the normal man curve. And this one has a bigger standard deviation because men walking around on the street do vary quite a bit. So variation is by how wide it is, and the area under both of them is 1, which I said there wasn't going to be any numbers, but that helps us work with 100% statistics stuff and probability stuff, which we will do in other videos. Thanks. That's all we have to say for now.